This is question number 8. We're told the curve C has equation y is equal to kx cubed minus x squared plus x minus 5, where k is a constant. In part A, for 2 marks, we need to find dy by dx. So all we're doing is differentiating both sides of the equation with respect to x. Remember, k is just a constant, it's just a number. So dy by dx on the left. If I differentiated x cubed, I would get 3x squared. So if I differentiate kx cubed, I'm going to get 3kx squared. If I differentiate x squared, I get 2x, so we're going to have minus 2x. If I differentiate x, I'm going to get 1, so I'll have plus 1. If I differentiate a constant, I'm going to get 0. So this is my expression for dy by dx. 3kx squared minus 2x plus 1. We're told the point A with x-coordinate negative 1/2 lies on C. The tangent to C at A is parallel to the line with equation 2y minus 7x plus 1 is equal to 0. We're asked to find in part B for 4 marks the value of k, and in part C for 2 marks the value of the y-coordinate of A. Let's start off with this line. I'm just going to rearrange this. So what we have now is 2y minus 7x plus 1 is equal to 0. So we can say that this is now 2y is equal to 7x minus 1, and that y is equal to 7 over 2x minus 1/2. We can see this is in the form y is equal to mx plus c, and m, which is the gradient, will be 7 over 2. All I'm going to do is set dy by dx, which of course is the gradient function, equal to 7 over 2, and I'm going to sub in the x-coordinate of A, which is negative 1/2. So that gives me 3k lots of negative 1/2, which we need to square. Then we're going to subtract 2 lots of negative 1/2, and then we're going to add 1. So let's go ahead and look at this. This is going to be 7 over 2. If I square this, I'm going to get positive 1/4, so that's 3k over 4. That's going to give me 1, and then we're going to have plus 1. So from this, now if I just subtract 2 from both sides, we're going to have 3 over 2 is equal to 3k over 4. If I divide both sides now by 3 over 4, we're going to end up with k is equal to 2. So the value of k is equal to 2. Let's now go ahead and substitute this in, and this will allow us to solve for c. So we've got y is equal to kx cubed, which becomes 2x cubed. We have on here now minus x squared, so minus x squared. Then we have plus the x, and then we have minus 5. So that's the original equation here, and I've just simply substituted in k is equal to 2. So let's evaluate the y-coordinate when the x-coordinate is negative 1/2. So we'll have 2 lots of negative 1/2, which we need to cube, minus the negative 1/2, which we need to square, plus now the negative 1/2, and then we're going to subtract 5. So that's going to give me now, this is going to give me negative 1/8, which is going to give me negative 1/4. This is going to be now minus another 1/4. This is going to be minus 1/2, and I'm just going to write that now as minus 2 over 4. And then we're going to get on here, the next one is going to be minus 20 over 4. I'm just making my fractions slightly easier to work with. Remember, this is a non-calculator paper. So that's going to give me now negative 24 over 4, which is going to give us now negative 6. So the y-coordinate at the point A is going to be negative 6.